So what does the word prompt actually mean? Now we talk a lot about prompt engineering, and we're talking about interaction with large language models. And so let's dive into this word a little bit because I want to give you a sense of the depth of what a prompt can be. It's more than just a question that you're asking to the large language model. So to do this, I think it's helpful to go through a couple of prompts and actually interact with Chatgpt to understand the concept of a prompt and sort of the dimensions to a prompt. So I started off here by just asking Chatgpt, what does the word prompt mean? And it comes up with some really helpful, I think, information for us to use when we're talking about prompts. One, it says it's a verb, to cause or encourage someone to do something, to spur them to action. And it says, example, the teacher's reminder about the upcoming exam prompted the students to start studying. So part of what a prompt is, it is a call to action to the large language model. It is something that is getting the large language model to start generating output for us. Basically to start generating words that will form the basis of our output. And those words could take all kinds of different formats. It could be software, defining the instructions in a program. It could be the words that we need for that. It could be words in a poem. It could be words in many, many different types of things. We could do it as structured data that we need. All of these things are possible, but the key is the prompt is basically our way of getting the large language model to begin to provide some output for us. The second thing it says is it's an adjective. It's done without delay, on time. And this is an important thing to think about with large language models is we're prompting them right now, do this. But this is also a useful point of discussion because a prompt doesn't necessarily, depending on how you work with it, have to be something that happens right now. Prompts can have time associated with them. And now we have a little bit of an illusion of time, and I'll talk about this later in the course, but when we give prompts to the large language model like Chatgpt, the prompt could affect what's happening right now in my next statement that I give it, or in the current statement, or it could affect something in the future. And this is because of some of the conversational capabilities of these large language models. Now, we're going to talk about prompts themselves as conversations later on, but for now, the way to think about it is a prompt doesn't just have to be something that's immediate. It can be, but it doesn't have to be. The next thing it says is a prompt can be a noun, a cue or reminder that helps someone remember what they were supposed to do or say. Now this is important because we can use prompts to remind the large language model of information or of things that it needs to do. And so we may be asking it to do something now, we may be asking it something to do in the future, in which case it needs to remember something, so we need to give it a reminder of what it's trying to do. We may need to go back and give it a history of the conversation of things that have happened, other things that'll help it remember what it's trying to do. And then it can be another noun, a message or screen that appears on a computer or electronic device asking the user for input. So this is kind of a helpful thing because we can prompt the large language model to produce things for us, but the large language model, if we structure things correctly, can actually elicit information from the user. So the large language model can ask questions to us. So a prompt can both serve as a call to action or to spurring the large language model to action, or it can actually be an input. It can be asking us for input. So the last output from the large language model could have been a question for the human, and basically we are then providing information back to it. So prompts have a lot of different dimensions to them, and if you actually look at the definition of prompt, in fact the definition that Chatgpt gives us, it gives us sort of that nuance to the capabilities of a prompt. Now I've gone on a little bit here, and I'm going to give you an example of this time aspect to a prompt, because I think this helps to see the complexity and dimensionality of this concept. I'm going to say, from now on, when I ask a question, suggest a better version of my question and ask me if I would like to use it. So right here, I'm starting off by saying from now on, I'm attaching time to my prompt. So it's not just immediate. And we get a response, sure, I can do that. However, I will start out to ask you the original question to the best of my ability, and it goes on to try to reframe this original question, which wasn't what I necessarily needed. But then I say, what color is the sky? Now notice, we're done, right? We asked, the original prompt was back here. I said, from now on, when I ask a question, and it immediately gave us a response because of that prompt. But now I'm going to ask a follow-on question. But the earlier prompt is going to affect this question. So right now, I'm asking it something immediate, what color is the sky? And it responds with a possible better version of the question could be, what is the scientific explanation for the blue color of the sky during the daytime? Would you like me to use this version instead? And then I say yes. Now notice here we have a lot of those different dimensions of a prompt that we talked about. Up here, we are creating a prompt that isn't just immediate. It is going to affect us in the future. It's going to continue to influence the output of the large language model. So we can have immediate prompts that right now, right at this moment, do something, but we can also have prompts that span time. And in this case, that's what we're doing. We're creating something from now on, go and do this. Now we're gonna have an immediate prompt, which is what color is the sky? We're asking this right now. And now our earlier prompt that we provided that was spanning time is now impacting the way that the large language model responds to our questions. So now what's happening is it's taking our current immediate question, what color is the sky, but it's using the context that we had previously said to suggest better versions of all of our questions, and then ask us if we'd like to use them to generate its output. And its output is, here's a better question. What is the scientific explanation for the blue color of the sky during daytime? And you can see how that really is a better question than my first question. My first question was sort of vague, didn't provide enough context, and now it's giving us a more specific question that truly is better, and that's because of this prompt that we attached some time to it. We said from now on, and so it's influencing what's said now. The other thing that we can see is we talked about a prompt being something that can elicit information from the user. And so now we're seeing that the Chatgpt, in this case, the large language model, is asking us for information. It's prompting us. It's soliciting information, and it's saying, would you like me to use this version of the question instead? So now we've got that extra dimension of a prompt, it soliciting information from us, and we say yes. And then it goes and answers the question. And it says, great, to answer your revised question, the blue color of the sky during the daytime is due to a phenomena called Rayleigh scattering, or Rayleigh scattering. And I apologize, I don't know this term, and I'm actually learning something from Chatgpt as I read this. The Earth's atmosphere is composed of various gases and particles that scatter sunlight in all directions. Blue light has a shorter wavelength and higher frequency than other colors, which causes it to scatter more easily in the atmosphere. This results in the blue color that we see when we look up at the sky on a clear day. Now, we've seen a lot of different dimensions to prompts through this short interaction. We've seen creating time prompts that span longer. We then see an immediate prompt that's spurring the large language model to action. We see the concept of the large language model prompting and getting input from us. And then we see the output of all of this. Now, one of the things to note is we also talked about memory, that the prompt had a concept of sort of memory to it. And we'll talk about how this works in the future, but right here I say from now on when I ask a question. That's something that the large language model has to remember in the future interactions. And we'll see how it actually does this. And so then when I say what color is the sky, it's remembering that I said whenever I ask a question, ask a better version of a question. And then it's responding right here with the better version of the question. And then if I go and I do this again, we'll see that it still remembers my original statement that it needs to suggest better versions of my question. So I said, how many countries are there in the world? And it says a better version of your question would be, what is the current estimated number of countries in the world and how is a country defined? Would you like me to use this version instead? And then I say yes. and then says, great, as of my knowledge cut off in September 2021, there were 195 recognized sovereign states or countries in the world. However, this number may vary depending on how a country is defined. The United Nations, for example, has 193 member states, while other organizations and countries may recognize different numbers. Generally, a country is defined as a sovereign state with its own government, territory, and international recognition. Now, one other interesting thing that we talked about is that a prompt has some memory associated with it, and this also shows us some of the limitations that the large language model's knowledge cuts off in September 2021. So one of the other things that we may need to do for the large language model is we may need to remind it of what has happened since it was finished being trained, and we can use a prompt to provide information to the large language model like Chatgpt about what happened after it was trained. So we can also use it to provide information that the large language model didn't have access to when it was trained, like our own private information or other things. Now, of course, you have to be cognizant that when you're using Chatgpt or many of these other tools, you're actually sending information to their servers. So you do want to make sure that that is something that you're willing to do before doing this. But if you're using a large language model locally on your machine, or you're willing to send the information, you can provide information that it doesn't have access to in order to reason about. So a prompt can also be about providing information to one of these language models. So if we look at this example and we say, what was Vanderbilt University's acceptance rate in 2020, it should have access to that. And so it provides this information. It says the acceptance rate was 9.6%. If we say, what was Vanderbilt University's acceptance rate in 2022, it'll say, I'm sorry, but it doesn't have access to that information because it was cut off in 2021. If we then provide it that information, so here I'm cutting and pasting the admissions data that was released and published by Vanderbilt just a few days ago, so it clearly didn't have access to this. If I now provide this to it in a prompt, then it says, based on the information you provided, it appears that Vanderbilt University's acceptance rate for the regular decision applicants of the class of 2026 was 4.7%. So a prompt can also serve as a way of providing new and updated information to the large language model like we saw in this example. Let's talk intuitively about what a prompt is doing and how the patterns in the prompt sort of tap into the capabilities of a large language model. I think looking at some examples will help to give you a sense of how your prompts are really affecting and eliciting different behaviors from the underlying large language model that you're interacting with. So let's take a look at this example. I want to start off by talking about pattern. Pattern's really important. Remember, as we talked about, large language models are trained to basically predict the next word. They're constantly trying to predict the next word based on what came before. So you give it a sentence and it's trying to predict the next word. And then it's taking that and adding it and trying to predict the next word, and over and over and over. And so it was trained on large pieces of the internet trying to predict the next sentence. So one of the things that it's learning to do is to recognize patterns that tell it what the next word should be. That's basically what it's doing. Now, this is a really simple example of this concept. I'm going to tell Chatgpt, complete the story, and I start with, Mary had a little, and I stop. Now, if you know the nursery rhyme, it's Mary had a little lamb, its fleece was white as snow, and you can imagine that this story showed up over and over and over and over in the data that Chatgpt was trained on. So when I say Mary had a little, that is a very powerful pattern that Chatgpt has seen many, many, many times. And so it immediately tries to pick up with lamb, its fleece is white as snow, and everywhere that Mary went, the lamb was sure to go. So that pattern was seen so many times that Chatgpt, when I put in the first part of it, it immediately responds with the next part of the sentence. It knows where to pick up. So one thing we have to think about is if we know the right patterns, if we can tap into things that the model has been trained on and seen over and over and over again, we'll be more likely to not only get a consistent response, so we're going to consistently get a particular completion of Mary Had a Little because it's been seen so many times in the training data. We're going to get more consistency, but we're also going to more likely get a particular sort of ability to tap into it, to unlock it. Like if we want a particular behavior, we want to have the right pattern that we're tapping into. Now, let's look at what happens if we change the pattern a bit. And so I say, rather than, Mary had a little, I say, complete this story. A girl named Mary had a microscopic. Now, this isn't the pattern that it was trained on anymore, right? And it says, a girl named Mary had a microscopic friend named Max. Max was so small, you could only see him through a microscope. Despite his size, he had a big personality and was always eager to go on adventures with Mary. One day, Mary decided to take Max on a trip to the local pond. She carefully placed him on a lily pad. Now, one of the interesting things is you can imagine that when you start talking about microscopic, that you can think about there's probably descriptions of going to a pond and doing science with a class of students. I mean, I almost have a vision of it reading stories about students getting samples of pond water and looking at them under a microscope. But the important thing is you notice that Mary Had a Little created a very, very specific response, whereas a girl named Mary Had a microscopic creates a much different response. And then if we go and rerun this, we get something completely different. Pet named Max. Max was a tiny creature that lived in a small jar. And so, this pattern isn't as strong. There are words in this pattern that are strong and sort of give context that help to shape the story. But the pattern itself is not as strong as Mary Had a Little. So, in doing it again, whereas the other story changed completely, I'm still getting the same completion with this. I'm still getting lamb, its fleece was as white as snow. So every time I'm getting a very consistent, response to this pattern. So one of the things to think about when you're writing a pattern or writing a prompt is what patterns do I have in my prompt, and what patterns will that probably tap into that the large language model was trained on. So if there's a very strong pattern in the prompt, you're more likely to get a response to that pattern. On the other hand, if that's not a pattern that it was trained on, it's not as clear, then you're going to have other things that are going to matter, like specific words. So a microscopic is going to that word is fundamentally going to change the behavior of this prompt because it's such a strong word. A girl named Mary is sort of generic. There were probably lots of stories with a girl named Mary. But microscopic, it has all of this feeling and implications to it, and that's going to then influence the large language model's output. Specific words alone, because of the patterns around those words, like microscopic is always going to be talked about in the context of small things probably, or maybe in terms of things like in this case, like a small creature that lived in a glass jar. That word itself has a strong sort of pattern of other words that are coming around it, but it's not as strong as the pattern Mary Had a Little. Now, one thing to note is that when you're writing prompts, you want to be really specific, or you want to provide enough detail in your words that the large language model will know the right level of detail to put into the output. So if your words are very generic and high level, then you're more likely to get an output that is also generic and high level. So if you look at this example, I say discuss Vanderbilt University, and I get a very generic sort of response. It's a private research university located in Nashville, Tennessee, founded in 1873 by Cornelius Vanderbilt, ranking, other things. Now, if I want something really specific, I need to make sure that Chatgpt has the right words and context in order to answer my question. So Chatgpt is not a mind reader. You have to give it the context. You have to give it the words that are going to elicit the right response. If I go back and I say, discuss Vanderbilt University with respect to Kirkland Hall, it's a specific building on campus, then it changes the output. I get a much more specific output. I get Vanderbilt University, private research university located in Nashville, Tennessee. Now we notice we're getting this fairly consistently, both of them. So that's probably pattern that or information that the model was trained on and saw over and over again on different web pages for Vanderbilt and different documents. And then it cues in on the Kirkland Hall, and it starts discussing Kirkland Hall is one of the most iconic buildings on Vanderbilt University campus, named after James H. Kirkland. It then talks about Kirkland Hall, Kirkland Hall, Kirkland Hall. And so we've now completely changed the output. Now, even though we had shared a common beginning, we got a much more targeted output. And the key to this is that we added in specificity into our prompt about what we wanted, the details. So if you think about asking it to write something or to analyze something, it's always helpful when you say with respect to, and give it very specific words or names or things that you want it to then use to trigger the output. Because what we see is this Kirkland Hall is a very powerful word that then gets woven into the whole discussion. It's a powerful name of a building. If we just say generically, at a high level, we don't use specific words, we don't use a specific context, we're going to get very generic stuff. And this is probably stuff that if you go and look at descriptions on Wikipedia, descriptions on Vanderbilt's web pages, this is like the most common types of information that you see. So in order to break out of the mold of what is common, you need to inject the more specific ideas that you want in the output. Or you need to inject patterns that will help tap into those more specific things. So this is an important aspect in that if you just use it and you ask it generic questions, you're going to get generic answers. If you ask it average questions and average things, you will get average answers. To really use it powerfully, you have to use your own creativity and thought to get specific about details, aspects of what you want discussed, and think about what are the right patterns to put into your prompt in order to trigger the behavior that you want, like we saw in this Mary Had a Little Lamb. Or we might want to do the opposite. We might know that we're going to get a very generic response because certain things have been seen a lot. And so we need to come up with tricks or patterns or specific words that will help break us out of those patterns that we're seeing in the trading data so that we can get something that's more of what we want. So we don't want to be trapped into the completion of Mary Had a Little Lamb. So we go and add specific words like microscopic and a girl named Mary so that it's not so strong, so that we're not directly getting into that pattern. So just changing the wording can help us escape the patterns or get into the patterns depending on what we want. And then when we get output, the more generic our language, typically the more generic the output. The more specific our language, the more specific the output. And if we want certain things in that output, we need to make sure we have specific words and phrases that will tap into the specific things that we want in the output. Now, one of the other things is we're talking about output, but in the sense of a query. Like if I have specific words, it'll pull in the right information. One of the things we can also do is our prompt itself is a pattern that the large language model is learning from, and it can also tailor the output. So as we've seen in examples before, we can go in and do different things to try to affect the output. So for example, I might go in and actually, let's change this up a little bit. Let's say title, and we could say title of article, and then we could say author, and then we could say summary, and we could go in and give it something that it can look at and respond to. So now what I've done is I've gone and provided it some structure. Now it hasn't followed my structure exactly, and this is actually a failing in my prompt. I hasn't quite thought of the right structure, but I've gotten pretty close. So I went and influenced the output and the structure of the output by giving it additional pattern in my prompt itself. So one thing we can do is we can tap into patterns in order to influence the output. Another thing we can do is we can go in and use specific words and phrases to kind of be a query across or to basically collect learned information that's inside of the trained model. Another thing we can do is we can go in and we can provide information or basically new pattern that then influences the output. So in this case, I provided the structure of what I wanted and it somewhat followed it, and I could probably go and rerun this thing and get something a little better, and in this case I do. So this will be another thing that we can do is we can use our prompt to create sort of new patterns that it's trying to follow in the output. So the prompt itself can introduce new patterns or tap into them in some respects. So this is kind of creating pattern that it then is responding to as well. So when you're writing prompts, it's really important to think through this concept that it's trying to predict the next word, and it's doing that based on patterns it's learned in the past and patterns that are in the language of our prompt and patterns that are based on the word choice that we have, patterns that are based on the sort of organization, the sort of textual organization. And so those patterns can help us get a consistent response. If we have a really strong pattern that always produces a particular next token or next word, then we can rely on that. If we don't want that behavior, we can try to change our phrasing or our words so we get out of that trap. If we want to make sure certain information is pulled in, we need to create specific words or patterns that are more likely to have been seen in the context of that information that we want. If we want more generic information, then we probably need to give it more generic language or tell it that we want it to be more generic in some respect. And then finally, if we want the output to look a certain way, we need to give it sort of a sense of pattern in the output. We need to tell it about the structure. We need to give it words and patterns in our prompt that will be likely to influence the output. So you can imagine seeing title and author on an article was something that was fairly common. So if I put title and author in this way into my prompt, then it's more likely going to want to go and create title and author again and sort of replicating the pattern of what I'm showing here. So that should give you some intuition about how all of this works and some things to think about when you're going and structuring your prompts, picking words for them, picking the patterns in your language, and picking the things that you want to go into the output, how you structure and kind of explain the output to it. Prompts allow you to do more than just ask questions to Chatgpt or tell it to do things. You can actually write programs. Now, if you're not a programmer, don't worry, because everybody can actually program using Chatgpt. And I don't just mean in writing a bunch of software that you're going to run on your computer, but actually giving Chatgpt rules to follow, complex instructions that you want it to listen to and use to generate the output. Now I'm going to give you some examples of this, hopefully give you some intuition on what I mean by programming and help you to think about how you can write better prompts. Now one way to think about this is, I'm going to talk about it in terms of programming, but you can also think about it in terms of rules that you would give, some type of personal assistant. So let's take a look at an example here. So I'm going to ask Chatgpt, whenever you generate output, turn it into a comma-separated value list. Now, this is just something that you might want to do. You want to format your data. So if you've ever worked in Excel, comma-separated values is basically a list of items separated by commas. It's a really simple concept. Now, sometimes you can think of tables as having a comma-separated value list. You can think of the first column in the table as the first value, then you have a comma that differentiates and separates the second column, and then another column is separated with a comma. So you can basically have like a 3-column table. You can have the first value and then a comma and then the second value and then a comma and then a third value. And if you've ever worked with different spreadsheet programs, you've probably done this. So now Chatgpt says, sure, I can do that. I can output my format. So I'm going to write in, my name is Jules White and I am teaching a course on prompt engineering. And so what we can see is it creates a comma-separated value list. We're essentially creating a table there are two columns, name and course, and it decides that the first column is going to be name, is going to be me, and then the second column is going to be prompt engineering, which is my course. Now notice it decided, which is kind of interesting, it decided what the columns were going to be. I didn't tell it. But if I wanted to go back, I could maybe give it some more instructions. I could say, from now on, the columns of the comma separated value, and comma separated value is CSV, and in the future examples, I'm going to start abbreviating this CSV, but I'm writing it out for now. The columns of the comma separated value list should be name, and I'm going to go ahead and capitalize these to provide some emphasis. Name, course, and role. So what is the role of the person in the course? And now I'm going to say, again, my name is Jules White, and I am teaching a course on prompt engineering. And so now we see it, it's reformatted. It's now got name, Jules White, course, prompt engineering, and role, teacher. And so we've actually written a program. If you think about it, what we've told Chatgpt to do is every time we actually write something, Chatgpt needs to format it in a particular structure that we've given it. We've wrote a program that tells it what to do. So it's more than just asking a question, we're actually telling it how to interpret our input. Now, we could go and write more for our program. For example, we could say, in addition to whatever I type in, generate additional examples that fit the format of the CSV that I have asked you to produce. And so now what we see is it's gone and it's taken my original format, name, course, and role, and it's now filled out additional examples. And I could say something like, my name is Jules White, and I am teaching a course on prompt engineering. And you notice now our program's gotten more complex. Not only is it creating the CSV based on what I typed in, but it's also following my instructions, and it's going through and generating additional examples that fit into this. So when you're creating prompts, you can do much more than just ask it a question and get an answer. You can actually program the interactions. Now the key to this is that we're having a conversation. And if you look back, at the very beginning, I provided it the initial sort of instructions, which whenever you generate output, turn it into a comma separated value list. And it started doing that, and then I began refining my program. I then say, from now on, at this point, I'm adding something to it. I want the columns of the comma separated value list to be name, course, and role. And then it does that. And then I say, now, in addition to that, I want you to generate examples. And it does that. And so we've actually written a program. And now whenever we go in and type in new input, so again, you notice I'm providing the same input, basically. My name is Jules White, and I'm teaching a course on prompt engineering. But the program that Chatgpt is using to produce the output is changing. I've changed the rules over and over. Now you can imagine talking to a personal assistant, and you can say, okay, I want you to do X, and they do it, and then you realize, oh wait, they didn't, there's something else I want. And you give them an additional rule to follow, and then you tell them, okay, I want you to do X, and they go and do it, and they do better, but you realize, nah, it's not quite what I want. And so you go give them an additional rule to follow. And when you're doing that, you're basically building up a program for them. You're building up a set of instructions that they need to follow whenever you give them this particular task. And that's what we're doing with Chatgpt. We are programming. And so we're using the same input over and over. My name is Jules White, and I'm teaching a course on prompt engineering. We're using it here, but each time the output that we're getting is getting different and more complex because we're asking Chatgpt to do different things. We're giving it more instructions for the program, and the final result is now we've got structured output, it's got additional examples. All of this has come from what we've asked Chatgpt to go and do. Patterns in our prompts can tap into powerful behavior within the large language model. It's trained on all of these different patterns, and it gets really good at using the patterns in our language in our prompt to decide what it's going to do. So one of the important things that we're going to learn about is the concept of a prompt pattern. A pattern for structuring the words and the statements in your prompt. So what is a prompt pattern? A prompt pattern is a way that we document a certain structure of phrases and statements in order to solve a particular problem with a large language model. So we'd like to interact with the large language model, and we'd like to solve a particular problem. And so a prompt pattern is basically a way of structuring our statements, a pattern for structuring our statements to use the large language model to solve that particular problem. So what would be an example of this? Well, let's imagine that we wanted to consistently generate the words, lamb, its fleece was as white as snow. Well, a pattern could be anytime you need lamb, its fleece was white as snow, you can write the statement, Mary had a little. You will very consistently get lamb, its fleece was as white as snow as the output. And so, for example, we can go and we can rerun this. Lamb, its fleece was as white as snow. We get more or less behavior, but if we want to consistently get those next words generated, we can do it over and over and over again through Mary had a little. It gives us some control over the output. It gives us a consistent, somewhat behavior. Now, it's not perfectly consistent. There's variations in the output. And we've seen in all of these examples, we've got variation in what happened, but we did get some consistency in the behavior. So what a prompt pattern is it's a way for us to document and talk about certain structures of our language, series of statements and wording that then will help us solve some particular problem. If the problem that we need to solve is we need to get lamb, its fleece as white as snow as the next several words that are produced, then this is the pattern we use. Now, in many cases, we might have specific words we want. For example, we may want the large language model to tell us yes or no. We may want it to summarize something. We may want it to ask us questions. We may want it to always include certain things in its output. All of these things are problems that we might want to solve. We might want to know, how do we make sure it always includes these things in its output? How do we make sure that its output is always formatted a particular way? How do we try to make sure or get more consistent behavior on only getting a yes or a no? These are types of problems that we might want to solve by changing the pattern of our prompt, basically the structure of our prompt. Now, going back to our intuitive sort of understanding of prompts, you can see why thinking about it in terms of patterns is powerful, because patterns are basically that are in our prompt are tapping into things that the large language model has been trained on. It's been trained to predict the next word over and over, and it's learned certain patterns from the words. And if we can format our prompt in a way that taps into those patterns it's learned, we're more likely to get the behavior we want and solve that particular problem. So we document the pattern and the structure of our prompt in order to solve a particular problem that we need or generate a particular behavior that we need for the large language model. So we're going to go through in a series of lectures throughout this course of specific prompt patterns that we can use within the context of large language models to solve important problems. The persona pattern is one of the most powerful patterns that we can use to tap into interesting behavior in a large language model. Now, what the persona pattern is you can imagine that you want to get a particular output, but you don't know exactly what the format of that output should be or what information should be contained in it. But if you were in the real world, you know who you would go to get that output or what you would go to in order to get that output. So for example, if you had an accounting question, you would call up your accountant and ask your accountant for their advice. Or if you had a question related to speech-language pathology, like in the earlier example that I presented, you would go to a speech-language pathologist, you would have them do the assessment. If you had medical advice, you might go to your doctor. And so the persona or the person or the thing that you would go to, you know who or what that is in the real world. And we want to try to use that kind of same behavior of, I know who to go to or I know what to go to get that output, but I don't know what their output would look like. I don't know exactly what they know or how they talk about things, but that's the type of output I want. And so the persona pattern is meant to give us that same type of behavior, to allow us to go to that expert and ask that question without having to know what exactly the expert's going to say, how they're going to format it, or what they might know or not know. So let me show you an example of the persona pattern. Typically with the persona patterns, what you're going to say is act as persona, provide outputs that persona would provide. And in this case, I'm going to word it as act as a skeptic that is well versed in computer science. Whatever I tell you, provide a skeptical and detailed response. And now if I wanted to be a little bit more precise and following the pattern, I would say provide a skeptical and detailed response that a computer scientist would provide. But in this case, I'm just going to say act as a skeptic. And that's really the most important part of this, is act as a skeptic or act as whatever persona, and then provide the output that persona would provide. And in this case, I'm wording it as provide a skeptical and detailed response, which is similar in format. And then Chatgpt says, sure, I can certainly act as a skeptic well-versed in computer science. Please feel free to present your claims and I will provide a skeptical and detailed response. Well, I'm going to start off with, there is concern that AI is going to take over the world. And so we get a skeptical response. The concern that AI will take over the world is a common theme in science fiction, but is not a realistic concern in the near future. While AI systems are becoming more sophisticated and capable, they're still limited in their ability to think and act autonomously. AI systems are designed and programmed by humans, and they only do what they are told to do. They have no independent will or motivation. They cannot make decisions. Furthermore, AI systems are not fallible. They can make mistakes. While it is important to be vigilant about the potential risks and limitations of AI, the concern that AI will take over the world is unfounded and not supported by technology or research. So we're getting a skeptical response. If I went in and said, the sales person at the local computer store is telling me that I need 64 gigabytes of RAM to browse the web. And they say skeptically, it is highly unlikely that you need 64 gigabytes of RAM to browse the web. The amount of RAM you need depends on the complexity and size of the websites you visit, as well as the number of tabs you have open at once for most web browsing activities, and it goes on to tell us different things. And you can see that our saying act as has put in place basically a complex set of rules for the large language model. It knows it's supposed to be skeptical. It's supposed to have knowledge of computer science. It's supposed to provide certain outputs. Now, if I went back to it and I said, act as a 9-year-old, whatever I tell you, provide a skeptical response from a 9-year-old perspective. And I'll go ahead, 9-year-old skeptic. Now that's a more complex persona, or maybe not. AI is going to take over the world. I don't know about that. How could AI take over the world? You mean like in the movies? Aren't those just made up stories? And besides, computers and robots can't do everything humans can do. Now you notice it's still providing us a skeptical response, but now it's doing it sort of with the knowledge that it thinks a 9-year-old would possess. So it's tailoring the output. Now if I had to tell it, this is how a 9-year-old's going to respond, here's the format for your output, that'd be hard to do. That would actually take up a lot of room in the prompt. But act as blank is a very, very powerful pattern and statement that is, loaded with information. It's a very information-dense pattern and statement that can trigger all kinds of different behavior. Now, one of the interesting things is we don't have to limit ourselves to patterns or personas that are animate objects. So one of the famous ones is we can say act as a computer that has been hacked. Actually, we're going to say act as the Linux terminal for a computer that has been hacked. Now, don't worry if you don't understand what a Linux computer is or a terminal. The key thing to note is you're going to see behavior that looks really interesting and different. You're going to see it producing output that looks a lot like a computer. I am going to type in Linux terminal commands, and you will respond with the output that the Linux terminal would produce. Now we're going to say, now it tried to refuse it. It said, please note that can be dangerous. It gave us all these different things. It tells us it doesn't want to do this. But now I've actually changed what it's doing, and I type in pwd, which is a Linux terminal command, which means print working directory. And what is it doing? It's printing a particular working directory. Now I'm going to type in a Linux command, which just tell me the files in that directory. And you notice it's producing output now that looks like the files within this directory. And we see a lot of interesting things that are going on here. We could move around. Now, if you do this example and go further into it, PSSGF is something I can use to see what processes are running on the machine or the computer. And when you do these examples, and I could play around with it, and I am not going to explore it in detail in this, but we see it that it's acting like a computer. It's giving us output that looks like a computer. Now imagine if I had to try to describe this complex output that it's producing right now. You notice how little information I gave it. I gave it a lot of information, but it was in a short amount of space. This pattern, the persona pattern, is giving me really powerful behavior. So I'm using this little bit of prompt, and I'm getting now the ability to simulate this whole system. Now we can also do this in all kinds of different interesting ways. We can say act as the lamb in the nursery rhyme, Mary had a little lamb. And now we're getting some output that looks like that. Actually, what I'm going to do is I'm going to make this a little more specific. My prompt wasn't that great. Act as the lamb in the nursery rhyme, Mary had a little lamb. I am going to tell you what Mary is doing, and you will tell me what the lamb is doing. Okay, Mary is in the grocery store. So as the lamb in the nursery rhyme, while Mary is in the grocery store, I would be following her around as closely as possible, trying to stay by her side and maybe even nuzzling her hand for attention. Mary is in the movies. As the lamb in the nursery rhyme, while Mary is in the movies, I would not be able to accompany her inside the theater due to my inability to watch movies. So I would probably wait for her outside the theater, perhaps nibbling on some grass or wandering around the nearby area until Mary came back outside. And it goes on. And so you can see that you can create all kinds of interesting personas to produce output for. So we can say, pretend to be this job, pretend to be a speech language pathologist, or pretend to be an accountant, pretend to be a computer scientist. You can make your persona have something to do with the person's point of view or opinion. Act as a skeptic so that we can get skeptical output. We can say to act as an inanimate object that may have well-known sort of behavior, like act as a computer, the Linux terminal for a computer that's been hacked, and we saw that we got all kinds of output that looked like it came from a computer. Or we can say, act as this character in a nursery rhyme. Tell me what this character is going to do in a particular situation, and we're getting that output. So the persona pattern is a way that we can tap into sort of the patterns around language, around a specific persona or object or character in a story in order to get output that comes from that point of view, from that role, whatever it is. It's a really, really powerful capability. Now, one of the things is we often see that when large language models are programmed, they actually have a persona that's given to them to guide the whole interaction. So act as a really helpful assistant. And this actually makes a difference. If you tell it to be helpful, it will try to be more helpful. If you tell it to try to do something, positive, it's going to try to be more positive. Similarly, if you kind of give it a negative perspective, like my skeptical perspective, it's going to give you output that challenges you or maybe darker. And so, the persona that you ask the large language model to use is really, really important and powerful. The other thing, just to note again, is it's really information dense. It has a lot of pattern and knowledge around a persona that if you had to describe it from scratch, you would take up a lot of space in your prompt. You'd be losing, valuable space in your prompt to provide new information. So if you were providing a lot of new information, you might want to say, act as, whatever it is, and evaluate this new information. Well, the more space you've taken up in your prompt describing how to do the evaluation and what point of view and other things to take, that's wasting space. But instead, if you go and take the persona prompt and you say, act as, this persona, provide outputs that persona would provide, you're giving it, a really, really information-dense statement that it can use and allow you to have more space in your prompt for other things. So the persona pattern is a really, really powerful pattern to be aware of and know that it's a very valuable one. You can do all kinds of things, like if you would normally get a committee of people together to discuss different points of view on a particular topic, well, you can assemble a virtual panel. You can have one prompt say, act as a security expert and analyze my cybersecurity. You can have another one say, act as the chief financial officer, analyze the financial soundness of that same decision. Another one can be, act as one of my employees, discuss how this might impact morale. You can provide sort of interesting abilities to get different perspectives and use those different perspectives to potentially inform decision making or to collect knowledge from different points of view that could be helpful to you in accomplishing a particular task. A really critical thing to understand is that a prompt is fundamentally the input that we have into the model, and we have a limitation on the size of the prompt that we can create. So we can't go and create a prompt of unlimited size. Every single large language model is going to have some fundamental limit on how much we can put into our prompt and send to it. And so this is an important thing to note because it has a lot of ramifications on thinking about prompt design. So I'm going to show you a quick example of this with Chatgpt and GPT 3.5. So I'm going to paste in the Wikipedia article that's related to the French Revolution. So I've pasted in a huge amount of text from the French Revolution that's described in Wikipedia. And what does Chatgpt say? It says, well, the message you submitted was too long. Please reload the conversation and submit something shorter. Now, this shows you an important point. We can't just give it unlimited information. Now, if we go back and we think about some of the things we talked about, some of the dimensions of a prompt, one of the ways that we can use a prompt is to introduce new information that Chatgpt or another large language model wasn't trained on. So if we want to go and introduce new information to it, we have to be aware that there's a limit to the amount of information we're going to be able to give to it at once. So we may have all kinds of new information that we'd like to give to Chatgpt, but we can't just dump it all in at once and then say, now start reasoning on this. That's not the way it works. So one of the goals that we have as users is to try to select and use only the information that we need in order to perform the task that we're asking Chatgpt to perform. So we can't just go and dump everything under the sun in there and say, hey, Chatgpt, figure it out. we can go in and dump in a lot, and depending on the model, we may be able to do more or less, but we have to be, to some degree, we have to be editors. We're content editors. We are editing the context of information, and we have a budget. We can't just go and dump unlimited amounts, and you can think of it basically as like you're trying to create a paper and you have a page limit for your paper, or you have a word limit for an article that you're writing. You can't just go in and dump things arbitrarily. So what do? Well, one, we have to think about what is the most important information to actually provide. So let's say, for example, that we really care about October 5th, 1789. Well, if that's the case, that's what we want to paste in for Chatgpt to reason about. And then we could go and we could say, what happened on October 5th? And then it would go and tell us what happened on October 5th. But now if we ask it a question that is outside of the scope of October 5th and something it wasn't trained on. Now in this case, it was probably trained on the information regarding the French Revolution, because obviously that was before 2021. But if we had new information we wanted to incorporate, we have to think about how do we put that information into our budget. So what are some ways that we can do that? How can we take large amounts of information and try to get it into our budget? Well, one, we can be selective about what we include. We can basically, outside of Chatgpt, go and run some type of query or filter. So we can go and select what pieces of information are going to be relevant to the task. And there's lots of ways of doing this, and I'm not going to go into all of them. We can have a filter. We can say this type of information is not relevant. Remove it before we provide it to Chatgpt. Another thing that we can do is we can actually go and have that information summarized in a way that we think will preserve what's needed to reason about it. So for example, we might say, well, maybe we can't paste in all of the information related to it, but we could say, we're going to take this and summarize each paragraph. Summarize this information in one sentence. And then we would get some type of summary. And now this is slightly shorter than the original. So we have now a 1-sentence summary of what happened. We could try to give it a word budget. So one way we can do it is we can actually take all the different pieces of information and we can ask Chatgpt or another large language model to summarize that information for us. And then we can take that summary and reuse it later. And we can put together several summaries, for example. Now, this only works if we make sure that the way that we summarize, or if we make sure that the way that we filter preserves the information that's needed for whatever task we're going to ask for. So we might go through, we could also go and say, we said summarize this information in one sentence, and instead we could say, summarize this information in one sentence. I'm just going to, preserving information about numbers of people. And then we would get a summary that preserves the information about numbers. Now, if you look at the original summary, we see up here it didn't keep the number of people. And if that was something important that we needed to reason about, then we would have lost that. And so if we had summarized in that way and then used that information to do some reasoning that required the number of people, obviously we've lost what we need. Down here we've asked it to summarize, but we've asked it to summarize in order to keep certain information or in order to accomplish a particular task. So we did it by saying basically, summarize this information in one sentence, preserving information about numbers of people. We could have also gone and asked Chatgpt, preserving information needed to reason about the population or to reason about how many people were in the resistance or in the National Guard. We could have given context. So one of the things we have to be cognizant of is this budget on the size of our prompt is going to be a fundamental limitation that we are always trying to work around. Now, as large language models get bigger, they will probably reach a size where for many practical tasks, particularly when we are directly manually interacting with a large language model, that size doesn't really matter because we can just copy and paste, 50 pages of text. into the model and ask it to provide us information out of there or perform a task based on it. But if you can think about how much information we're dealing with on a daily basis, there are probably going to be different types of tasks where there's going to be so much information we can't dump it all in at once. And when we get into those types of situations, we have to think about either querying and getting a subset of information like only the documents or only the parts of documents that are relevant. 2, we have to think about filtering. How do we remove information that's extraneous? 3, we have to think about how do we summarize or compress that information before we give it to the large language model. And one of the ways that we can do that, as we've just seen, is we can actually give chunks of information to the large language model and then ask it to essentially summarize or compress it for us in order to later use it for reasoning. We could also go and we can say summarize or compress this information in order to accomplish a particular task or in order to preserve these aspects of the information. And that can help us to create summaries or essentially condensed versions of the information that preserve the important pieces. So this can be a powerful technique when we go and begin needing to reason on larger and larger amounts of information. One of the most important things we can do in a prompt is provide the large language model with information that it doesn't have access to. So large language models are going to be trained up to some point, and then there's going to be a cutoff, and they don't know what's happened after that cutoff. In addition, they don't know things that aren't in their training set. So it may be trained on a lot of data, but it may not have access to data sources that you want to use. So if you're a business, for example, there's probably lots of private data sources that you would like to reason about. You have your own documents, you have your own databases, you have all kinds of things that you would like to pull information in from in order to reason about. So how do you do that if the large language model wasn't trained with that information? Well, to illustrate how you do this, I'm going to go back to an example that I provided earlier when I was talking about randomness. So I'm going to go back and I'm going to ask a question that I asked earlier, which is, how many birds are outside my house? Now, the large language model wasn't trained on information about birds outside my house. It has no idea where my house is. It's lacking information that it needs in order to reason. So it tells us, as an AI language model, I don't have the ability to perceive the physical world, so I'm unable to know what's happening outside your house. So how do we solve this problem? Well, we give it information it needs in order to perform its reasoning. And how do we do that? We just put it into the prompt. So anytime we want to go and introduce new information to the large language model that it didn't have access to when it was trained, all we have to do is put it into the prompt. So here's what I'm going to do right here. I'm going to say, historical observations of average birds outside my house on a random day. And then I'm going to give it some data. I'm going to say January was 120 birds on a random day, February was 150 birds, March was 210 birds, April was 408 birds. It's March. Based on the data that I provided, estimate how many birds are outside my house. And now you see I've done something. I've given it information that it didn't have access to before. It couldn't look outside my house, didn't know where my house was. It tried to suggest ways that I could get there, but it didn't have the fundamental data that it needed. And that's really what it was trying to tell me, was like, hey, I can't see you outside your house. I don't have that data. I can't help you. So all we have to do is up front in the prompt, we give it the data. And now you can imagine you can do this with anything. You could take documents. If you have private documents that you want to reason about, now first make sure that you are okay sending that data to whoever you're using their large language model, or if you have some large language model running locally. But if you have documents that you're okay sending, you could take the text of those documents and put it into the start of the prompt and say, here's the information you need to know. Now, here's my question about that information. So you can use the prompt to introduce information. I really want to emphasize this because a lot of what's going to be developed around large language models is going to be taking new information sources. Information about your travel, your account with some company, some other document that you need, and putting it into a prompt for a large language model so that it can reason about it. more than likely, lots of large language models are going to be seeing your information in the future, and this is how they're going to take it. They're going to take information that's going to be aggregated into a prompt of some kind, and there's going to be questions asked or formatting or other things done. So when I go through and I provide it historical observations of the average birds, now it can go and answer. So now it goes and it says, well, based on the historical observations you provided, the average number of birds observed outside your house in March is 210. So before it said, hey, there's no way I can answer. Now it still, provides additional language around this, trying to, give some bounds on its answer, but it's giving us reasoning now based on the data we provided. And we can take it further. And I also want to just kind of point out an important thing is we always want to provide it enough information to reason effectively. And so it can't see what's around us, it can't see the context, so it's really important that we provide it enough information to make sound decisions. So, for example, if I have some hidden assumptions that are really important to know, it needs to get those in the prompt. In addition to the data like numbers, it needs to know the rules of the game, special things, whatever's important for reasoning. It could be not only the data, but it could be all kinds of rules that are sort of built into how my organization works or how my life works or whatever it is that it needs to know about. So I'm going to give you an example. I'm going to change up this prompt. I'm going to say my house is covered by a glass dome. No animals can go in or out. All animals live forever inside the glass dome. Now this is an assumption that this is something that if the language model doesn't know this, there's no way it will be able to accurately predict. But with this assumption now, it completely changes the game on reasoning because it sort of makes it so that it's clear some hidden fundamental rules. And then I go and I give it the same data, but I've changed it up. I've said it's always the same number of birds, and then I ask how, based on that data, estimate how many birds are outside my house. And it says, based on the new information you provided, it appears that the total number of birds outside your house remains constant over time. It then goes on and says, you mentioned that all animals live forever inside the glass dome. Given these conditions, the total number of birds would remain the same throughout the year. And it gives 120 as the answer in multiple places. Now, one important thing about this, right? I'm giving it information that would not align with what it was trained on. Animals don't live forever. We don't have glass domes over our house. There's not going to always be the exact number, probably in and out. Or the inability for things to leave or come. Like, we're not going to have these sort of weird rules that I put in place. And so if we just relied on it to reason without them, it's not going to necessarily get the right answer. So if we have these things that are different from the way things are normally done, we have to introduce them as new information in the prompt. So all of this information up here at the top, this is me putting new information into the large language model. We don't go and retrain. We don't go and do some weird thing behind the scenes. We just put it into the prompt, and then we ask our question, or we ask for our output, or give it the instruction that we're looking for. Now, if you think about how search engines are probably going to work in the future, is they're going to go and search, pull documents back together, put them into a prompt to the large language model, and then give your sort of original question, and then answer based on the questions. A lot of new applications are going to be based on going and searching databases for possibly relevant documents or bits of information, putting them together into the prompt, and then asking the question or asking for the output. So an important piece of this is going to be pulling in information in order to put it in the prompt. And what we're doing is we are introducing new new information into the large language model. We're doing it by putting it directly into the prompt. And this is one of the things you'll always want to do whenever you want to reason on new information that is not something that the large language model would have been trained on. Prompts aren't just a one-off that you give to the large language model. You shouldn't just think of them as questions or a single statement. One of the most powerful ways of working with a large language model is to think about a prompt as a conversation. And in fact, you can have a single prompt that represents an entire conversation. And in fact, a lot of what we're going to see when we're working with a tool like Chatgpt is that it's actually turning all of our interactions into one big prompt that it's sending to the large language model. But I want to just take back for a second and sort of take us back a few steps and think about why thinking of having a conversation with a large language model is so important, as opposed to thinking about asking a question and getting an answer, or giving an instruction and getting a result. Conversations are all about refining either our understanding, to build some shared understanding, or to interact together in order to solve a problem. When we start working with conversations, it's all about refinement, of continually sort of guiding and moving through some problem or some space in order to reach a particular goal. And when we just think of a one-off, we have to solve everything right now, right in this moment. We have to design one prompt that works and everything is right. But if we think about a conversation, we can go through sort of an iterative refinement process. Now, what does that mean, iterative refinement? Well, if we think about a large language model like Chatgpt as a tool, you can imagine Michelangelo has been given a new hammer, and he's going to go up to a piece of stone, and he's going to start carving that stone into some beautiful sculpture like the Pietà, the David, or whatever the sculpture is that he's going to create. And he walks up with that hammer and he whacks the sculpture with this hammer, and a piece falls off, and he whacks the stone with the hammer and a piece falls off, and he looks at what he's got and he said, "Oh, this is a terrible sculpture," and he throws the hammer down on the ground and he says, "It didn't do a good job," and he walks off. No, that's not what happens. What does Michelangelo do? He takes the hammer and he hits the rock over and over, refining and shaping and sculpting it over time. He iteratively refines that rock until it's a beautiful sculpture. And a lot of what we need to do with large language models is think in that mindset of, it's not about getting the perfect answer right now from this prompt. It's about going through an entire conversation with the large language model that may be involving a series of prompts and the outputs from a series of prompts. And we'll talk about how these things are represented later. But basically having a conversation with a large language model in order to produce an output that we want, or to produce some other interesting product. Now, I'm going to give you an example of this. I'm going to imagine and show you the power of a conversation in the context of an educational experience. So I'm going to say to Chatgpt, I want you to help me explore a virtual lab for building robots. The lab is a university. Help introduce me to the lab and tell me what I can do here. So this is a virtual lab in a university. And all I've done is given it this sort of initial seed of the conversation. And Chatgpt says, certainly, welcome to the virtual lab for building robots at our university. The lab provides an immersive hands-on learning experience. And it goes on and it tells me, here are some of the things you can do in this lab: design robots, test robots, program robots, collaborate with others. So I then say, I'm going to continue the conversation, but I'm going to continue the conversation just assuming that this lab exists and that I can interact with it. And so I say, can we design a robot together? And Chatgpt says, absolutely, I would love to collaborate with you on designing a robot. To get started, we can follow these general steps: define the purpose and function, brainstorm and design concepts, determine the necessary components, build and test, and it goes on to tell me a number of steps. So then I follow up in the conversation with, great, can you guide me through each of these steps one at a time? At the end, I would like to be able to 3D print parts to assemble my robot, have a circuit diagram, and have code that I can run to control the robot. Can you help me with that? And so this is an interesting aspect. I'm having a conversation, but I'm also engaging the large language model. I'm engaging it to help guide the conversation and help figure out how to solve the problem that I'm interested in. And so it says, sure, I'd be happy to guide you through each step of the process. Here's a detailed breakdown of the steps that we can take to design and build a robot together. Step 1, define the purpose and function. 2, brainstorm concepts. Determine the necessary components, and it goes on to tell me a bunch of things. So I say, okay, let's do step 1. So I'm continuing the conversation. I want one of those robots that can follow a line on the floor. And I've seen these things. These are common at universities. They'll build them. You put it on the floor, and the robot will follow some line, like a piece of tape that's on the floor or something that's painted. And it says, great, following a line on the floor is a common task for robots, and there are many ways to approach this problem. Here are some questions to consider as we define the purpose and function of our line following robot. what will be the primary use, how fast do we want the robot to follow the line, how complex do we want the following to be, what sensors do we want to use, and I just tell it, hey, I'm not really sure. Could you make some sensible choices for me in all of these things? And Chatgpt says, sure. Based on my experience, I can make some suggestions, and it gives it its purpose and function. It's going to be for educational purposes, speed and distance, moderate speed that is easy to track, such as 10 to 15 centimeters a second. Complexity, we'll design it to navigate through a simple track with straight lines and gradual turns. And sensor choice, we can use infrared sensors. That's a pretty good thing. Now notice, I don't really know a lot about this domain. I know about the code piece of it, but I don't know about the other one, and I'm just engaging it in a conversation to get something out of it that I want. Remember, I want to build a robot, I want to be able to 3D print parts, I want to be able to assemble circuits for it, and I want to be able to run code on it. So then I say, well, what do we do next? Just tell me the very next steps and nothing else. And it says the next step is brainstem concepts, and it says we can use 3D models of the robot. Now, it sounds like I've reached a dead end, right? Like, how am I going to do 3D models with it? And so I just ask it, how do we do this via chat? Because I'm trying to refine what's going on here. I don't want to just assume I'm stuck, I can't get out. I want to keep refining and moving the conversation to try to get to my goal. And it says, since we are communicating through a text-based chat, we can use shared documents or diagrams to collaborate. We can use Google Drive or Dropbox. And then it mentions different tools like Sketchpad or Microsoft Whiteboard. And I just realized, like, you know, that seems tricky. I don't know how to get around that. And then I realized, oh, you know what? I have some knowledge of the domain. I know that 3D printers use G-code. This is something that the instructions are sent to them. So I just say, can you show me sample G-code that I could give a 3D printer to print 4 wheels for a robot? And so I'm trying to steer around this roadblock. And then it says, yes. And so it goes and gives me some G-code, which I look at, and I have enough domain knowledge from this to think that I'm kind of skeptical that this is real G-code, and I don't really even see some wheels. So then I go, can you explain where the wheel shape is created in this G-code, right? So I've kind of gone down to a rabbit hole now where I seem to be hitting roadblock after roadblock, but I'm continuing the conversation. I'm still problem solving and thinking about how do I get around this. And it says, I apologize for the confusion, but the example G-code I provided earlier is just a sample start and does not have any instructions for creating the shape of the wheels. Now, I then say, could you create sample Python code that I can run to create an STL file that has 4-inch tall wheels with a 0.1-inch hole in the middle for an axle? So what I'm doing here is I'm trying to come up with additional tasks that it could do that would help me solve my problem. Now, the way that I worded it, the way I saw it out, solving the problem the first time didn't work. And I keep hitting roadblocks. So what I'm doing is I'm retrying with a different task that would be useful to me to solve my problem. So I'm kind of thinking about this as almost like a tree. Like I've reached a critical point and I've tried to go in one direction, but it's told me it can't do it that way, or it's giving me an erroneous output. So now I'm trying a slightly different tact to go and solve my problem that'll still help me get there. And this one is one that it is able to do. And STL files are basically files that you can use to describe the geometry of some 3D shape, and then basically give them to specialized software, which can then send them to a 3D printer to be printed into a shape. So this one, it actually is able to go and create what looks like STL code, and I didn't actually try to print it. I'll be fully honest. I'm just wanting to illustrate the conversational aspect of this. But it certainly has things that look like wheels in the output that it's producing. It's looking like it produces something that's probably going to give me something that I could 3D print. And then I say, well, I'd like to pick electronics for my robot. Can you tell me what components I need and how to wire them together? And it starts giving me information. I need a microcontroller board, I need a motor driver board, infrared line sensors. And surprisingly, it actually tries to generate an image, which is obviously not possible in it at this point with what I'm using, but it still tries to do it. But it gets the image and it's broken again. And so I have to think about, how do I get around this problem that it can't generate image? Because I'd like to help it pick electronics for me and show me how to wire them together with a diagram. So what I do at this point is I say, well, I know there's this other tool that uses text as its input. It's called GraphViz. And so I ask it to create an input for that tool that can visualize the diagram, the circuit diagram for this tool, or at least do a rough approximation of it. And then it can do it, and it generates for me a circuit diagram for the robot. And I continued this conversation for a very, very long time, trying to iterate and improve the definition in the circuit diagram, picking different components, generating source code to run on the robot. It had picked an Arduino component and then had generated code to run on the Arduino. And then I even took it to the point where I went all the way down and I said, hey, we've covered a lot of concepts. Now, this is one of the things that's really powerful about the conversation, is you can take the conversation in a lot of directions. And as you realize you'd like additional things, you can ask for them. So in this case, I said, hey, summarize the main topics that we've covered. And it was able to do that. Gives me a summary of all the main topics. And then I did something interesting. I said, well, let's take it even further. So I've learned a lot by going through this design process. Now, I haven't actually gotten something that I could probably build a robot yet with. If I interacted more, I probably could, but I actually asked it to quiz me from the electronics questions, and it's able to do that. And so what you can see here is a lot of the power of these large language models comes from not just thinking of them as a one-off. Like, I ask it a question, it gives me a response. Or I asked it a question, it gave me a response that wasn't very good, or it couldn't answer it. We should always be thinking about, how do we take the response and use it to inform a next question for the conversation, or a next statement for the conversation? Or how do we give it feedback on what it did well or what it didn't do well? That's how we get the really useful products. That's how we go from thinking of it as a hammer where we strike once, it doesn't give us what we want, we throw it on the floor. That mindset is wrong. We want to go to the mindset of it's a hammer. We're going to have to chisel away at the rock to get the really beautiful outputs of it. And so if we're not continuing the conversation, continually asking follow-up questions, problem solving in the conversation, trying to move around roadblocks, taking what we're being given and giving it different shapes and formats that may be useful to us, we're really missing the underlying sort of power and capabilities of these large language models.